As everybody knows, each graduate student trying to graduate, the word graduate says you want to graduate. So if you're trying to finish a program by completing a paper, a thesis, presentation, what have you, this process is for you. iGRIND. Well, I stands for ideation. It's about coming up with ideas that you are interested in. And I think the topic of research people ask about, how do I find the right topic of research when they first start? Well, I think there are three things that are required for that: interest, expertise, and visibility. You have to be fully invested, and if you're putting in already 5+ years, more like 6 years or 7 years to a particular niche idea or question, then you better have a pretty invested in big interest in learning more about it, improving on it, and actually coming through with the full project. You also want to make sure that your team, whether it be your advisor, your collaborators, or your committees, actually have the right expertise that you need for the project. Because without the background information, without the knowledge for using a particular tool that's required, it makes it so much more difficult, not impossible, but so much more difficult to get this stuff started. If you have easier access to the right skills and knowledge, that makes it so much more the better and easier. So you don't have to figure out things by yourself and you're the only one working on it. And this is technically a one-person project. The feasibility is really the funding, the access to tools that you have, and really the access to other resources that you need. If you're trying to complete a human subject study and you need a particular type of subjects or patients that are hard to come by, let's say you're working on a disease that is so rare that you can only find subjects once in a blue moon, that you're not going to have enough time to get all the data that is required to answer your questions. Again, not impossible. It just takes some more time and effort and energy on your part to finish your project. So something to keep in mind. If you are working with a particular experimentation tool, like fMRI or a biological cell experiment or something like that, and there are certain types of questions that are better answered with certain methods. And so you have to kind of think about what exactly is best answered with your tool that's available. Again, this is a great idea to think about what methods you like to learn, what you'll be interested in using, and whether the type of question that you're trying to answer makes sense to answer with that method. So that's the ideation. I think it helps to have the curiosity, the interest, to keep asking, to keep learning, to keep improving on the methods that you are already working on. And that really increases the chance of potentially coming up with a brand new idea, brand new discoveries that your field is excited to see. Okay? The next is G in the iGRIND. G is the gap analysis. The goal of gap analysis is to really position your project into a bigger context. What does that mean? When people say that gap analysis in academic research, we talk about what's known and unknown separated, right? We have to see what's been previously studied, and this is by reading papers, doing literature review, and seeing what others have tried along with this topic, and what's still unknown, and that's the gap that you're trying to fill. What exactly is that gap that is still unmet, and not just figuring out what hasn't been done before, because plenty of things that haven't been done before, but also coming up with ideas to figure out why that's important. And this is answering the so what question. And this is important because this is helping you communicate the novelty and significance of your project. Every grant application, every paper, pretty much every talk that you will give really requires your understanding of what's known, what's not known, and why that's important for you to work on that research, why this project is important, right? So having that idea flushed out before you go on the actual experimentation really helps you contextualize okay, where does my project fit into this bigger context? And don't worry, this is something that comes with practice and time. I honestly didn't know what my project was until the last bit of my PhD, because that took time and a lot of practice and a lot of reading, a lot of troubleshooting to really get a good sense of where does my project fit and what this is not. So be able to ask the right question from the ideation standpoint. And then in the gap analysis, you want to turn that into the significance, why that's important, being able to communicate that. The next R is research design. And this is kind of where a lot of people get hung up on with the designing experiments. Designing experiments isn't just about designing what to do on the day of experimentation. It's actually what it is more about is designing the analysis and designing the structure or the flow of the story that your project is about, that you're writing a paper. And so having that visualized earlier on really helps you figure out what's still needed, and check your progress and what else we can do to make this even more impactful. So the number one thing is having an idealized title, and this is coming with the first stage, the ideation part. It helps you to have an idea of what is the question you're answering, right? The bigger picture that you're trying to address. Turn that into a hypothesis, and then turning that into kind of a hook. A title is like a hook of a story. So a few different title ideas to really hone in on what is the significance, what this project really answers, and what is the most impactful thing that the idealized paper could be about this topic, right? So I always had a running list of title ideas. And in fact, at the end of my project, I had no idea my title that was actually published in Nature was very close to what I had imagined 3-4 years before. And so this shows how important it is to visualize what the project could be, and then consistently asking yourself questions about what data do we need, what else do I need to do to address these potential concerns, and what other things can be done to refine either the analysis or the presentation or the communication of it. Designing experiments, and as far as visualizing the experiments, I actually sketch out the actual data that you like to see. So when you have a title, right, you want to have the list of figures planned out, like idealized figures, drawn out, sketched out, what have you, and really label it. Like you label the x-axis, y-axis, the type of figure that you would need. And this really helps you to visualize this in a visual data form, because one, that's something that you have to do that anyways. But two, do that before even the data collection happens, so that you know exactly what type of data you need to collect, what sort of quantity of data you need to collect. And then you also know potentially the type of tools needed for analyses. Sometimes you require a programming language, or sometimes you need a new open source tool that you may need to install, or what have you. These are the things that you have to think about. What sort of proofs or things to show to make your point across, get your point across in your story makes sense. Like trying to visualize that earlier on really helps. A couple tips for that. One is to, when you read the papers, save all the figures, like screenshot of each figure that you actually admire and you like to emulate. The things that you liked about a figure, or things that you wouldn't want to do, like potentially its color scheme, or the way the data is visualized in a sequential form wasn't really working, or the things that you like and things you don't like about a particular figure, and then you keep a note of that. That really helps later on to keep thinking about what data am I collecting, what my project is about, why that is important, and why does it need to be done this way, potentially versus another way, because there's 50,000 different ways to draw the same figure or show the same data. And you want to make sure that this is the most effective way to communicate what you're trying to show, what your story is in a visual form, that it clearly is communicating to the person that you're trying to reach. Okay, and then the other thing is that the idolized figure list isn't to make it that this is the end all be all. It's actually a iterated process. So you may realize as you do your experiments and collect data and analysis, you might realize that these are not actually correct and you have to update them. And more likely than not, you're going to have to update the figures as you go. And so keeping the running list of the figures that you have in mind from the get-go, and then updating with the dates to keep track of what changed, what things got omitted, or what things need to be updated to refine and really update the title as well as you go. Maybe your hypothesis is not exactly correct and you have to refine that and change it, adjust it as you go. The I is implementation. So implementing the design, the plans into the action, so execution. Obviously, when you have a plan, it doesn't mean that it's going to go exactly the way you intended to. But there are two different types of troubleshooting. One is technical and the other is conceptual. And I think the technical troubleshooting is what was most common for me earlier on when I was still learning new techniques and tools, really the research methods. For example, doing surgeries for mice because my experiment requires surgeries. Or doing some recordings, and all of that needed to be learned and refined. And so that was the technical issues that I had to troubleshoot. There are a lot of problems that happen to address and have to figure out on your own, because there are things that need to be addressed before you can go to the next part, the next step. Right. But then later on, in the later stage in my experience, I had more of a conceptual troubleshooting. This is where the hypothesis being wrong might be an offshoot. There are lists of things that I didn't realize could go wrong or be more difficult to prove, or it may not be as impactful. And so I had to kind of troubleshoot and pivot and shift. It's kind of like pivoting your project in entrepreneurship. You constantly have to update your project in a way that aligns with the final outcome or the final desires of the customers. And who is the customer? In science, is the public or the grant committee. So these are the people that you need to speak to, and you have to think about what needs to be updated, what additional experiments or tools do I need to verify my hypothesis is correct, or to address somebody's concerns about this particular issue in a project. Always thinking in the back of my mind, what would a reviewer see in this? Particularly if a reviewer doesn't like the idea of it, what would make them cranky? Like, I just imagined a cranky reviewer reviewing this and thought about what would I have an issue with? What kind of things would they ask about? What are the things that I could address even before they could become an issue? So before you even present or you submit a paper to a journal, you address that even before. And of course, you're going to have other additional questions and things to address, but at least you have you have done your part to make sure that reduces the amount of time that potentially is needed for review process. The end is note-taking, and I think notes are really important. In our lab, it was absolutely necessary to document everything, because without documentation, we don't know exactly what we did, even though you think that you're going to remember. Just a couple days before what you did seems like it's fresh in your mind, you're not going to remember exact details. And so I had the habit of actually having my notes either digitally or physically to write as I go, type as I go. And then it really helped me to remember, refresh my mind not based off of my memory, but also actually having a physical thing to go back on and say, hey, I did this. I used this millimeters of thing or this milliliters of product or whatever. And those details really help when you have a documentation and you already have basically written a methods section of your paper. Which, by the way, documentation really isn't just about for you to remember. It's actually a part of the writing process. This entire thing, the whole purpose of this is to write and to present, right? This is to present your technical information into a specific audience. And so putting that into visual form so everyone else can see your ideas in your head will really help. And one of the easiest things to write and earliest things to write is the methods. What exactly did you do? What steps did you take to get to this final outcome? And while you're doing it in the experimentation, you note take and make sure that you save it, which could be turned into a methods section of your paper or even entirely a methods paper. For example, if you're establishing a new technique in your lab, that might be a great way to get additional paper on top of your main paper for the actual outcomes of the research. But methods in and of itself could be a paper. So something to keep in mind if you have a really good documentation and you can prove why that's important to implement in different contexts of a research experience. Finally, D is the deliverable. Deliver whatever you have in a journal article or your thesis defense, your general talk to the general audience. All of that is requiring the full steps from ideation to the product. And it's really turning the idea into a product. And it's essentially the same thing as in business. Now I see so many things are so similar between academia and business that it's kind of like it's essentially the same thing. Like gap analysis, for example, in my mind is like a market research in business, trying to figure out what's been done, what hasn't been done, trying to understand the customer profile, understanding the audience so that you can tailor your talk, your storytelling methods. All of that is so similar across whether you're in academia continually or you are moving into industry or start a new business. And so all the skills that you're learning here is so transferable. And these are not the skills that only are going to get you a paper or a talk to be successful in grad school, but these are also the same skills that will be really putting you far in advance in business context. So I hope that it helps. Let me know what sort of projects that you're working on, and I'm really curious to see what sort of fields of study that people are in, and trying to make these videos as impactful and effective and useful to you as possible. So thank you for watching, and I'll see you next time.